Welcome back to the channel. Today we're going to start machining the valves and the retainers first, and then we'll get to making the springs. We'll go over that later. But the first thing we're going to do is machine the valves. And the stem on these valves are 0.93 diameter, so that's really thin. They're an inch long. It'll be a little bit shorter than that with the where the 45-degree angle is there. But it's still a very long section to turn to 0.93, which can cause some issues. And you can make these out of steel or stainless steel. I've got some stainless steel piece of scrap here that we're going to turn these out of. So there's a few different ways to attack this. We'll look at a few different options. So first thing you can do, you can turn it conventionally. So if you have your piece here, so you can start turning with your tool, going this way, and then you can just work off a little bit at a time, the full distance. So whatever your machine will handle and your tools, 20 thousandths, 40 thousandths at a time, just keep working it off. The problem with this is once it starts getting too thin, the piece wants to bend and deflect that way, so you get tapering here. Another option would be to support the end here. So if you could put a dead center in this end. It needs to be a little bit longer because you're going to probably want to cut that off. So you can support the end either with a dead center, or if you have a tailstock, a chuck that goes into your tailstock, you could use that. Whatever you've got, you could support the end. That is definitely an option to do. Like I say, make this a little bit longer. You'll turn down a longer section because you probably don't want this in the end of your valve. For the exhaust valve, you definitely don't want this, because on this engine we have a rocker arm that opens it. On the intake valve it would be okay, but you'll want to make it a little bit longer and then cut this off afterwards. Like I say, a viable option. Part of the problem is getting this end cut off, because if you put any kind of force against it here, this is going to want to bend. There are some ways around that. Another option, which I learned from Joe Pye over at Advanced Innovations, he makes small cuts here on the end to know how much to turn off to get to the diameter that he wants. And then he is able to take all this off at one cut. That, because you have the material behind here to support it, it's not going to deflect. You can only make one cut though. You only got one shot at this. If you go back to make a second cut, it's going to deflect. So with my machines and my tools, and especially cutting in stainless, that usually doesn't want to take that big of a cut. But that is definitely a doable option. Another method that I've seen is to support the end here somehow, either with a dead center or tailstock chuck or something, but actually work the section out between two pieces here. So this stays at the diameter that you start with, and this stays at the diameter you start with. You'd probably want to use a cutoff tool and then feed into this direction, and then you can feed in a little bit and travel across and work it out. Definitely a doable option. My method that I prefer to use, that I've used more successfully, is to actually work it down in sections. So we will turn, I don't know, 150, 200 thousandths or something section here down to the diameter that we want. So because you're turning such a short section here at a time, it doesn't really deflect. You get the deflection when you have the long section here because it's got more of a lever arm. So if you turn a short section, turn it down to the diameter that you want, and then come down and then turn another section, then you can keep working your way down that bar. And you can turn this as small as you wanted to and as long as you wanted to. Just keep working your way down the bar, working in sections. So I found that this works pretty good. What I've done on the last engine that I made, I actually left this like a thou to a thou and a half or so oversized. And then I'll show you when we get to it, but I have an adapter where I can put my Dremel tool in my tool post holder to act like a tool post grinder. So then I will actually grind that last thou to thou and a half or so off of this. And with very, very, very light pressure with the grinding wheel so that it doesn't deflect this bar, we'll only take off like maybe half a thou or a few tenths at a time. But then I will actually grind it once I cut that down, and that gives you a good, straight, nice, smooth finish. So it'll slide in the guides good and be a good fit in the guides. So like I say, we'll actually grind that last thou to thou and a half or so off of this. And I'll show you when we get to it. You'll see it on the video, but you can actually take some Sharpie and Sharpie this thing up, and it'll look perfectly smooth once you've cut it. But then you run that grinding wheel down it, and you can start to see your machining marks, or if it has any deflection, it'll hit in some areas and not in the others. So you'll work that down till you get it cleaned up and then get it to final size. So enough talking. We will get this bar set up in the lathe and start machining on it. Okay, so I got the valves machined now. That all went pretty good. Got the teeny tiny 40 thousandths hole drilled in the end. So we ended up tearing this down and then put the Dremel in there and then ground it to fit. It leaves a good smooth finish on it. And then I actually, once I parted them off, I put it back in a collet chuck and then set the grinder up and ground this 45-degree angle on there, sort of like you would on with a valve grinder on an actual valve. So that all went good. Made the retainers. They're extremely tiny and hard to see. And the retainer pins, which I made them out of a piece of music wire that I just cut off. So the next step that we need to do is lap these valves in, and we'll put them in here, and then I've got a pin vise here to hold them on the back side so I can put a little bit of pressure on it and we can lap them in. So to lap it in the past I have tried automotive valve lapping compound, but it's just too aggressive for brass, or the Upture engine that I had actually had aluminum seats in it. It had the seats directly into the head, and it leaves swirls in there that's hard to get to seal. So what I've been using is it's polishing compound for rocks, and I'll put a description up here so show you a picture of what that looks like. But it's a really fine powder, and it comes in different grits. And then what I did is mix it with a little bit of oil. That's the coarsest grit there. Mix it with just a little bit of oil and then use that. And I got 3 different grades here to lap, and that's the finest. It's almost like a talcum powder. So we'll go through these 3 grits, put a little bit on there, and then lap it in. And like I say, this is for polishing. It's pretty cheap on Amazon. It's for polishing rocks in like a rock tumbler. It's kind of like a real fine powder. But just mix it with some oil, and that makes real good valve lapping compound. So we'll get some of this on here and get the valve lapped in and see how it's seating, and make sure that it's making contact 360 degrees around. Okay, so I got those lapped in, and to check them, we can put a vacuum cap here on the back side, because there will be some air that will escape past between the guide and the valve stem. So then we'll put a little bit of oil on here and we'll blow into it and see if we see any bubbles. Hold down on it just a little bit. I don't see any major leaks. You can tell a difference in the sound if the valve's up. It's real easy to push on it. And then it gets real hard to push the air in once it closes. So I think that's good. We'll check the other one, and then if you do get bubbles or around there, or it's leaking a little bit, just keep lapping it in, and then you can try going back to the fine compound first, and then if that doesn't work, go back to the coarse and medium, work your way back through it, and just keep lapping them until you get a good tight seal there. That's probably one of the hardest things to do when building at least a model gas engine is to get these valves to seal. Sometimes it can be difficult. Just keep lapping it in until you get it to seal. So that's going to do it for this episode. Come back next time and we're going to make a mandrel and wind the intake and exhaust valve springs, and then we'll start working on the exhaust. Thanks for watching.